Good morning, sir. We are going to present our chosen topic entitled The Significance of Engineering Geology to Construction.
Angelica Lislap.
I am Go Ami D.
I am Gonzales Tricia S.
I am Hardin Kimberly E. From Bachelor of Science in Civil Engineering 2A.
Next is journal citation from Edelston M. Walthall, S. Cripps, J.C. and Calshaw, M.G. 1995. Engineering Geology of Construction, Geological Society, Engineering Geology, Special Publication number 10, page 3 to 29.
In the background of study, this may contain the benefit to understand the related part of geology to construction. The continuation of it is very particular to road safety. International Association of Engineering Geology simply says that this is all about the investigation of a particular conflict area and the study of its condition, and also coming up with the best solution of engineering. Also the different environmental problems, as well as the activity of man, the prediction, and the prevention of geological hazards. In this case, it is very important that we have solutions to any geological hazards that arises. So, on the next slides, you're gonna know more about things in geological hazards. The first topic is all about excavation. It is the action of excavating o yung paghukay. It is formed through the development or construction of its foundations, tunnels, or underground. The main importance of it is the formation of excavation should be highly formed well, for its stability will stay at its most durable condition. So yun, dapat matibay po. Kasi once na hindi ganun ka durable yung slope, maaari siyang mag-collapse or gumuho. So kailangan po na stable lang yung strength no. So according to Neil is specifically concerned with the ground conditions. Yun yung pinaka-concern na yun sa mga grounds. So, usually, in identifying hazard situations, yung mga panganib na pwedeng mag-occur that can cause harm during the excavation and construction. During doon sa pagko-construct ng excavation or yung paghuhukay ng lupa para mag-form ng slope or ng paggawa ng embankment doon. So all these concerns is related with the engineering geology. Civil engineering, works and construction industries mainly cover the functions and the construction process in geology are very important. So the next topic is all about slope stability. From the word slope, which is matarik o mataas, and from the word stability, for the things being stable. So, the construction of slopes arises through the formation of embankments with fill and the removal of ground to produce a cutting or a flat platform. Yung pag-construct nito is through the formation ng embankments or wall o yung nakikita natin sa gilid ng daan, yung mga matataas na part. Ito ay nagtataglay ng safety sa road na nagpe-prevent ng river flooding sa isang area. Kinokontract nito yung soil para maiwasan ang erosion o pagguho ng lupa, especially yung mga nasa gilid ng daanan na maaring magkaroon ng harmful sa ibang tao. In forming the slope, dapat matibay yung pagkakagawa kasi nakadepende sa tibay nito yung foundation ng embankment para hindi mag-cause ng conflict o hindi gumuho yung lupa.
For the method excavation, the optimal excavation method for a given situation is determined by the ground characteristics, water conditions, and other elements related to the excavation sites. The equipment available for the actual process, as well as, if necessary, for sustaining the ground afterwards, may influence the decisions. There are two distinctions of excavation, the soft ground and the hard ground. For the soft ground, in this category of ground, it includes unconsolidated sedimentary deposits, lacking cementation, and highly fractured or deposit rocks, which can be excavated using hand tools and machine excavations like bulldozer, and face shovel. In this excavation, kailangan gumamit ng mga riven techniques and other methods so that we can loosen the ground bago tayo mag-proceed sa paghuhukay. Sa paghuhukay ng lupa, mayroong mga major importance sa pagpili ng mga gagamiting excavation equipment, and it depends on its strength, bulk density, bulk factor, and natural water content. But there is no generally accepted quantitative measure sa paghuhukay. The assessment is usually made according to the experience of the operator and to the behavior of the ground. According to Atkinson, ang pinakakaraniwang way or method upang matukoy kung ang rock masses is capable of being ripped is seismic refraction. The practical limit for ripping is a seismic velocity of about 2 km per second. And on the other hand, light blasting or hydraulic fracturing ay maaaring magdulot ng mas stronger na ground to make it ready for ripping. Next is tunnel. Tunnel construction necessitates a significant amount of geological input. Maintenance of excavation surfaces, stability, as well as difficulties with excavation operations are all construction issues. The linearity of tunnels complicates the examination of the ground prior to the construction. This is critical because even minor deviation from projected geological conditions can create delays and increase cost because the structure design and excavation and support methods will not be optimal. Difficulties may also occur as a result of the presence of materials having unusual negative characteristics. For example, some rocks disintegrated easily during excavation, and the resulting slurry can be difficult to remove from the excavation if the circumstances are damp. When undesirable features run parallel to the tunnel alignment rather than crossing it at a step angle, the situation is generally more serious. For machine tunneling and hard rocks, mechanical cutting using tunnel boring machine or blasting is used in hard rock tunneling. This performance of tunnel boring machine is more sensitive to changes in rock properties than conventional drilling and blasting techniques. Aside from ground stability and support, cutter wear rate and penetration rate are also important economic factors in machine tunneling. Next is drilling and blasting. These procedures are the traditional means of advancing a tunnel in hard rock. A full face can be defined in variable or poor ground. A top heading and bench or similar procedure may be more appropriate. Drilling and blasting may harm the rock mass depending on the qualities of the rock mass at sa paggamit ng blasting techniques. This may increase the need for ground support, also the amount of water na pumapasok sa excavation. Ito ay pwedeng maging dahilan upang makompromise ang stability ng ine-excavate. Next is instability and support. The length of time that unsupported rock mass can survive in a tunnel is mostly determined by the size of the stresses within the unsupported mass. The size and the shape of the tunnel in relation to the intercom strength of the rock mass concern the nature of the discontinuities, the geostatic stress regime, degree of overbreak, the groundwater pressure, the method of excavation, the length of time before placing the permanent lining, and the stiffness of the lining system, all influence rock pressure on the tunneling. For the classification of rock for support, the classification rock masses allows the determination of the most appropriate method of excavation for the rock mass in question, as well as the design of the kind of tunnel support. This classification is based on the fundamental qualities of the rock mass, and it must be relevant to both drill, hole core, and direct observation of the rock mass. The rock mass quality, together with support, pressure, and dimension, and purpose of the underground excavation, are used to estimate the type of suitable permanent support. The next one is influence of joints and faults. If the orientation and type of the discontinuities are outside of the expected ranges, unexpected instability may emerge. Overbreak can cause issues such as excessive handling and the need for backfilling. But instability can also be a hazard during construction. Next is tunneling and soft ground. In soft ground, immediate ground support is critical. Hence, tunneling is normally done with a shield. This shield is a cylindrical drum with a cutting edge around the circumference that is pushed forward as the digging progresses. The excavation can be performed either manual or mechanical means. But with rotary cutting head tunneling machines, there is a danger of over-excavation. However, this problem can overcome by using compressed air, working, or resorting to a pressurized soft and medium clays. Shells and highly weathered bentonite slurry shield to support the face. The next one is water and tunnels. Tunnels and other underground opening and water-bearing ground faces numerous challenges. It is vital to guarantee that sufficient pumping capacity is available to deal with the continuous input water in excavation. Any sudden and unexpected water inflows that would result into being flooded. Ang tamang pag-estimate ng water inflow into a project tunnel ay mahalaga dahil ang high inflows ay nagiging dahilan upang hindi mag-operate ang isang tunnel. Measures to control water infiltration, such as general lowering of groundwater levels in the area and ground treatment, may be done in the flows into underground excavation are excessive. The last one is gases and high-temperature tunnels. The pores in space and rock can be occupied by naturally occurring gas. If this is kept under strain, it may rupture into subsurface workings, triggering explosive rock failures. Maraming gases na magiging hazardous if they come into contact with tunneling equipment. For example, methane is an inflammable and explosive gas that occurs in many formations, including coal measure strata. Also, other examples of gases are carbon dioxide, carbon monoxide, sulfur dioxide, and hydrogen sulfide, which are toxic and very hazardous.
As we proceed to the foundation is the most important part of it, as it carries the weight of the entire building. Foundation keeps the building up when the forces of nature try to take it down. And it needs to build well. There are things to consider in building a foundation. First is the waterlogged ground. As we know, building in waterlogged area is not the best choice. And if it is can't help, an engineer need to be aware of the dangers it represents. Because as the water seeps into the foundation will get weaker that will lead the building to collapse. Next is soil condition. As the different types of soil can break or make the foundation of structure. For example, loam, rock, and sand gravel foundation are friendly soil, while peat, clay, and silt are bad options because they tend to change their structure or shift that can cause cracks in the foundation to turn the weakened whole structure. Third one is erosion of the ground. It is need to be taken into account when designing the foundation because erosion of the ground can cause shifts and mess with the structure. Followed by the effects and after effects of construction itself. It is construction itself has effect on the ground. For example, vibration from the piling or changes made in excavation. That's why site inspection is needed before and after the construction starts. Also, cost and speed is need to be considered. It can be less avoided by hiring reliable and experienced contractor. Last is the effects of construction on the adjoining structures. If works threaten surrounding building, you may be or the contractor may be accountable and you can be prosecuted. Excavation, dewatering, and vibration are similarly the harmful effects. For the statement of the problem, the study implies that the significance of engineering geology to construction is needed to minimize catastrophic events as a result of man's impact on the ground. Concerning the impact of contamination and waste disposal. For the methodology, the author did not include methodology as the study focused on the significance of engineering geology to construction.
Next is recommendation. So, any possible problem should be given adequate attention during site investigation stage. So, there should be effort to acquire the required information for the design of structures because leaving uncertainty about engineering geological condition can lead to over optimistic views of the ground condition being taken. So, if the risk of delay during construction is very high, it can be justified. So, conclusion. This paper discusses the important contribution of engineering geology in the process of excavation, particularly the influence of geology on cut slope stability, soft and hard ground excavation, bearing capacity, settlement, subsidence, and the foundation type are all considered. Also, the problems associated within the use of fuels and waste materials are mentioned. So, the contribution of the engineering geology helps in pointing out the possible problems that will arise in the interaction between geology and the works and activities of men, as well as in preventing geological problems.